everyone. Today our group Mr. Jokers want to talk about managing IS and IT projects, analysis of IS failure cases. Okay, first of all, I will introduce the whole structure of our presentation. At the beginning, we will give a brief introduction about what is IT and IS. After that, we will involve the explanation about IS and IT projects management. Furthermore, we will state some data to present the current state IS and IT project measured and have a deeply to analyze what are the key factors can cause IS project failure or success. Moreover, the most important part of our presentation is to evaluate the IS failure through two cases. Finally, based on the failure experiences, we need to have plans to improve the IS management. Okay, let's talk about this diagram then. The first part, what is IS and IT? Today, it is widely recognized that information system knowledge is essential for managers because most organizations need information systems to service and proper. An information system contains information about an organization and its surrounding environment. There are three activities: input, processing, and output. In an information system, produce the information that organizations need to make decisions, control operations, analyze problems, and create new products or service. IS also requires feedback, which output is returned to the appropriate members to organization to help them evaluate or correct input. In addition, let's look at another diagram. In addition, user information system effectively requires an understanding of the organization, management, and information technology to shape the system. Now, let's make attention to the part of IT project management. Project management is the application of the modern management techniques and system to implement a project from start to finish. Our projects are constrained by three factors, which are cost, time, and scope. For a project to be successful, these three factors constraints must be in equilibrium. Any changes to one factor will have an impact on the others. Now let's talk about the fact about project failure. We give two real data to mention this part. One of the data is from the dynamic market surveys about 880 managers. And we can see about 62% of the IT projects fail to meet their schedules. And there are other 3A data to show that they have surfacing different difficulties such as the budget overruns. The second data, we use a bar chart to show each percentage of projects successful, failed, and challenged. We can see that failed and challenges have a large percentage as well. Next, there are considered number of factors can illustrate why IS and IT project failure. Here we briefly give some top rating factors such as poor planning, unclear goals and objectives, lack of support and user involvement, and inappropriate skills and so on. Based on these reasons, we will later use two cases to discuss more details. Now let's move on to the case study. I will pass this part to my colleagues.
Now I'm going to talk about the first case study, which is baggage handling system at the Denver International Airport. It is one of the most notorious examples of project failure. Firstly, I would like to give brief background information about Denver International Airport. Denver has traditionally been home to one of the busier airports in the nation because of its location. Faced with the great capacity of airport, Denver decided to construct a new state-of-the-art airport that would cement Denver's position as an airport transportation hub. It is the largest international airport in the United States and the third largest international airport in the world. In 2010, Denver International Airport was the 10th busiest airport in the world with 52 million passengers. Because of its limitation of the traditional baggage handling system, that is too labor-intensive, slow, and expensive. So the Denver airport contracts with BAE to design a unique system. BAE was a world leader in the supply, installation, and operation of baggage handling system. There are several goals about the project. It was originally designed to distribute all baggages, including transfers, automatically between check-in and aircraft and pickup on arrival. This is why it's called an integrated automatic baggage handling system. The system was supposed to improve ground efficiency. Aircraft turnaround time was to be reduced to as little as 30 minutes. The Denver system was originally designed to deliver bags much faster than the current norms at major airports. The maximum delivery time was apparently set 20 minutes for narrow-body and 30 minutes for wide-body aircraft. It also was supposed to reduce flight delays, shorten waiting times and luggage carousels, and save airlines in labor costs. However, unfortunately, there are massive problems plagued this automatic baggage handling system. This problem caused the airport's opening time was delayed. From the timeline, we can clearly see the opening time has changed 4 times, and the amount of the delay is about 16 months. In addition, the airport owners suffer losses to the extent that the automatic baggage handling system does not deliver the productivity and efficiency that they had bargained for. The total cost overrun is about 3 billion, and the delay have also cost them around $500 million on the date, and it costs about $33 million a month. Finally, in August 2005, it became public knowledge that United would abandon the system. Now, let's look at news about the baggage system in more details.
A few years back, it was built right up there with Lindbergh's flight to Paris and Chuck Yeager breaking the sound barrier. It was the revolutionary and speedy new baggage system at Denver's then shiny new airport. But that was years ago. United Airlines uses the system and has lost a ton of money and a lot of bags. It never really worked. Tonight, there is word it will soon be gone. As for our correspondent tonight, well, here's a hint. When Roger O'Neill first started covering this debacle, he was a much younger man.
It launched, chewed up, and spit out bags so often, it became known as the baggage system from hell.
The airport opening should be rescheduled.
Not once, no more delays, but 2, not to worry, 3.
We'll pay for it.
No, 4 times.
Will this system ever work like it was supposed to?
It kept Denver's shiny new airport from opening. And when it finally did open, that is, the baggage system didn't. It was such a colossal failure, every airline but United refused to use it.
Honey, back on here.
And now, finally, miserably, even United is throwing in the towel. By Labor Day, the system was reported will be shut off. Back to old reliable tugs and carts. Aviation consultant Michael Boyd.
United wanted a system that would move hundreds of thousands of bags quickly and efficiently, and basically couldn't move a Barbie doll efficiently.
The airline, which wouldn't talk on camera, told NBC News it will save $1 million a year in maintenance costs. and much more if it can get out of a $60 million a year equipment lease, which runs until the year 2025.
People who have tried to make the baggage system work say it's always been a bunch of scrap. And that's likely where it'll end up now, on the scrap pile, fetching somewhere between $60 and $90 a ton.
Like the joke, how many engineers does it take to change? It took 10 years and at least $600 million to figure out big muscles, not computers, can best move baggage. Roger O'Neill, NBC News, Denver.
Now I will move next part to my colleague.
So now I'm going to explain why the handling system project was failed. There are two aspects leads the failure: technical and management level. First, I will talk about the technical part. First of all, the basic problem of IS failure is underestimate complexity of the project. New Denver Airport has successfully used a small scale of baggage system, but they have not functioned together in such a large system. In fact, because no airline has used a fully automatic system, to deliver a time-sensitive for baggage system, it represents a huge technical risk if they undertake this project. Moreover, the BAE design is not just an increase in complexity, it is a leap in technology. It features 12 times as many cars as in the existing comparable system. For example, the system must track tens of thousands of bags going to hundreds of destinations in real time. In addition, the software must be recovered from errors very rapidly, besides regular error checking. The second issue is that they fail to test after implementation. Monash Airport experts advise Denver to leave plenty of time and resources for testing, because the technician did not take the advice. But the technician did not take the advice. The BAE has run out of time for testing because they have spent too much time in developing the system. In fact, they have scheduled 21 months plan without including physical testing of the full system design. Even they try to test the system, it seems very difficult and time-consuming than they anticipate. Because they did not run the test, they found many issues when they first start to use the system. Thirdly is in terms of the management. DIA struck with poor design and planning of the project. BAE was brought on board 2 years after construction of the airport has already begun. Hence, many problems arise because the baggage handling system design is not fit the airport design. For example, the teller cars, it's the vehicle that carries a bag. They had to make it sharp to make the tracks at the corner because the tunnel was too narrow. They also have unrealistic timeline and fail to recognize associated risk. They did not understand the complexity of the project and overestimate the ability of implementation, and therefore they have to delay their project for 16 months. Also, they have changed the design after they found the unfit of physical building structure, and they add the ski equipment racks after work have already completed. This implies the management did not take responsibility of the project and get involved with the project. So last but not the least, there is a little communication between airport designer and management and the BAE designer. In the result, they plan and process the project without understanding the complexity. They also did not understand how a change of one part of the system would impact the rest of the system. Many of the change had required a significant redesign of proportional work have already completed. It may result even more troubles. So in fact, both system designer and the project managers of the DIA has ignored the expert advice, and they decide to proceed the project despite it unfeasible. So overall, because of four main factors, the IS project is failed. So now my colleague will introduce you to the second case study.
This case study is about an examination of an information system development project that failed.
They will talk about a breakdown of major issues that causes the failure of the project and the subsequent steps to correct the existing problems. First, I will introduce the background of this case study. Because of increasing demands being placed on a fixed amount of land, a state planning agency was believed that there was the need for a better land management. The agency thus needed a management information system to aid its planning process to approach the problem of formulating state policies. The failure of the project was not due to mistakes made by specific groups or individuals, but to the inability of interacting organizations to align their management goals and policies. The agency contracted a local university's research group to solve the problem. And the URG organized a framework to work on the project. A special project team which is made up of the researchers and the system groups. The project team focused on the problem and developed the theoretical models, and the data was connected to physics models. In this case study, the most failures was due to management inability to control, organize, and plan, which is to say manage. The main causes are as follows. The first one is the inactive decision maker. The agency had no land-use planning decision history it could fall back on. The agency's problem process had not yet been developed at the time they contracted for the IS. The agency, in fact, still in the process of defining its role in the state bureaucracy. Another one is the contract defenses. The project goals was as vague as to improve the land use decisions, then the contract was equally as vague in its description of what the URG was to produce. There was no formal work plan submitted to the agency. Third one is the project control. The agency should neither the contract nor a work plan contain exact specification of what the URG was to produce. Control over development become a moot point. Last one is the single system approach. One of the ICE design errors frequently made is the attempt to solve a multi-system information problem with the single system approach. The agency apparently viewed its information needs as if it were an island in the state organization, and as such wanted its own semi-private information system. The concept of the single information system belongs to the agency was considered for a foregone conclusion. Okay, let's move on to the next to my partner to explain the next part of the case study.
Okay, let's move on to the fourth problem, which is the system user identification. An IS developed by the URG as the contract required should be handed over to the agency as the system was completed. However, the real result is that the agency was not designed to be the user within the system. Instead, the URG viewed itself as a user within the system. It is the problem when identifying the researchers as the system's user, since they were defining the information needs and developing the decision structures. The next one is data collection. The data selection was decided by the researchers since the agency was not considered to be the first user of the IS. This resulted in the errors of data collection for the agency. The agency was outside of the research that it didn't know the specifics of the problems which needed to be solved. In other words, the agency did not take part in the decisions and examination structures of which data variables to collect. Thus, it turned to the URG for help, whereas the URG was unaware of what kind of data should be sufficient and appropriate for the data collection and the results of the research. All this would lead to the syndrome and data security, and the researcher the security which appeared because both agency and the researchers had no definition of the decision-making or the problem-solving process. And then the final problem is optive decision process. The project compared the actual decision process represented by the URG displayed in the case with the decision processing model designed by Herman Simon. Because the decision process of the IS user is crucial to successful information system design, these two figures both have three phases of intelligence, design, and choice. Simon considers these three phases as related elements in a continuous process, which exhibited as a flow from intelligence to design and then choice. And from the other figure, that the decision process built by the agency and the URG is similar to that of Simon's, but as an optive one. The choice phase is not entered in the flow. Consequently, such an optive process would become degenerative. Okay, it comes to the conclusions of this case study. The errors in system development in the case just examined form a degenerative network that is difficult to escape once it is entered. So the main error should be the network. And the two reasons is the inactivity or immaturity of the agency's decision-making process, and the other one is the lack of involvement by systems analyzed in the original definition of the agency's information needs. When it comes to fourth consequences, as the first one is unwarranted trust, weak contract, single system, and the degenerative circle. The main failure should complain the top managers of the project, but not the researchers and the planning agency, and not the URG. Okay, we will move on to the final conclusion.
Okay, let's conclusion. There's two projects. Both these projects present unsuccessful information system development. As we have seen, there are so many failure factors. This can summarize into four aspects, such as the shareholder, the top management support, and the lack of the communication, and the level of the complexity. We should keep this in mind to ensure system success. Okay, let's talk about this into the detail. The first one, the user environment. It's an important part of the information system and can improve system quality and enable successful system implementation. The second part is about the top management support. Every study about the system success or failure identifies top management support as the critical successful factors. Without the full commitment from top management, when the problem arises, the project will fail. And the third one is about the level of the risk. In the PowerPoint, all projects can be made to look simple, but in the real situation, it's much more complex, and we should be care about the business objective, structure, and the firm basic requirement. Failure to see this complex will lead not only to underestimation of the schedule and budget, but many other problems. And the last part is about the management of the implementation process. The first one is about the data migration. It should be planned for the early in any project. In fact, it could be considered a separate project entirely. This can be due to inadequate training of the user, poor transition from old to new system, and lack of user support for the new system. So we should build a formal methodology to give the reliable estimate. And the
The last one is the technical leadership. Just as the building needs architect, software system needs a technical lead. To be successful, the technical lead must be in control of the project, especially the data module and the application design. This level of the authority must be recognized and acknowledged by everyone involved. Otherwise, each portion of the system may be constructed individually, and the pieces will fit together at the end. Okay, that's the reference for our group work, and thank you very much.